we'll now look at one law associated with the fluid pressures, that is Pascal's law. Pascal's law. So we have studied something about the fluids, that is fluids exert pressure in all directions. Similar to that, when a pressure is exerted on the fluid, for example, if at all I have a fluid taken into a column which has a different cross-sectional area like this, if at all you have a U-tube which has two different cross-sectional areas. Here I am filling with the liquid, I am filling with the fluid over here. Fluid in the sense generally I am taking a liquid, or even with the gases also you can do. For the sake of convenience I am doing this with the liquid. So when a liquid is filled in the limbs of this U-tube having different cross-sectional areas, and here I have a piston. Here I have a piston. This is the piston I have. Here I have a handle. Now I am exerting the force, let us say F1, and area of the piston is A1. Then the pressure exerted here P1 is equal to F1 by A1, and that is transmitted through this liquid into the other end. So the pressure is transmitted undiminished. This is what called as the Pascal law. Whenever a pressure is exerted, here you have the different cross-sectional area. The piston is having different cross-sectional area A2, and here you have a handle over here. So this pressure will be acting on this handle. So when this is pushed down, this will be lifted up with a force F2. So according to Pascal's law, P1 is equal to P2, which means F1 by A1 is equal to F2 by A2, which indicates that the Pascal's law clearly tells whenever pressure is exerted on the fluid, that pressure will be transmitted equally through every point. So whatever the pressure applied here is transmitted to the other end without diminishing. That means the pressure is transmitted from one end to the other end undiminished. This is what called as the Pascal's law. And two things you need to remember here. One thing is fluid exerts pressure in all directions, and whenever pressure is exerted on the fluid, it will be transmitted through all the parts without diminishing. These are the 2 points you need to remember. And in this particular chapter, one more thing you need to remember is whenever you are taking a body, into a fluid, depending upon its density. For example, if I look at the cork and a stone, if at all I take the cork, a wooden cork over here and a stone, then in case of the stone is sinking. This is the stone which sinks and this is the cork which floats, because density of the cork is less than density of water. That is the reason if the density is less than the fluid what you have taken, here if I have taken the water over here, then density of the cork is less than density of water, therefore it is floats. And another thing is density of stone is greater than density of water, therefore it sinks. Density of water therefore sinks. So remember that if you are taking any fluid, when a body is thrown into that, if the density of the body is less than the density of fluid, it floats. If the density of the body is more than the density of water or density of fluid, whatever you are taking, then it sinks. You need to remember these 2 points. This is how the flotation works. And one more point, one more definition you need to know in this particular chapter is relative density. Relative density. So relative density is nothing but It's a ratio of density of body divided by density of water. So you can define the relative density as ratio of density of the body to the density of water, and the units for the relative density coming out to be no units, because it's nothing but a ratio. Ratios generally do not have any units. Therefore, relative density has no units for relative density. So these are the three things you need to remember in this particular chapter. One is Pascal's law. So 2 points you need to remember in case of the fluid pressure. Fluid exert pressure in all directions on the walls of a container, and similarly whenever the pressure is exerted on the fluid, it is transmitted throughout the fluid undiminished, which is called as Pascal's law. And whenever the bodies are dropped into the fluid, depending upon their densities, if the density is less than the fluid, it floats. If the density is more, then it sinks. As an example, we have seen the cork and sink here. And the last term that we can define over here is, what does it mean by a relative density? Relative density is nothing but the ratio of density of a body, whatever the body you are taking, and the density of water. Since it's a ratio, it has no units. So these are the terms we need to associate with the fluid pressures.